Bismillah, alhamdulillah, wassalam, wassalam. Our lesson today we are talking about the irrational. We know the rational number. It's mean the number as a form a over b. Q is the rational number. It's mean the number in the form a over b, where a and b belong to z and b doesn't equal 0. Any fraction, it's mean rational numbers. And a and b belong to z and b doesn't equal 0. What about the irrational numbers? Irrational number, it's any roots. We can't write it as a rational form. For example, root 4. Root 4 equals 2, because 2 times 2 equals 4. Root 25 equals 5, because 5 times 5 equals 25. What about root 3? We can't find the number time itself equals 3, so root 3 is a rational number. A rational number, any roots, we can't find it as a rational form. For example, the square root of non-perfect square, like root 5, we can't find number time itself equal 5. It's not perfect square. Root 3, root 7, root 2, root 5 over 8, and so on. And the cubic roots of non-perfect cube number. For example, the cube root of 8 equals 2, because 2 times 2 times 2 equals 8. So 8 is a perfect cube number. What about cubic root of 5? We can't find number time itself 3 times equal 5. So cubic root of 5 is a rational number. Like cubic root of 2, cubic root of 5, because we can't find number time itself 3 times equal 2, and so on. And approximating value by to 22 over 7, but by doesn't equal exactly 20 over 7. It's approximate to 20 over 7, or 3.14. The number 22 over 7 is rational, but the symbol by is a rational number. Example: show which number belong to Q and which number belong to Q dash. Q is a rational, Q dash is a rational number. Root 0.49 by calculator or factorization. Square root of 0.49 equal 0.7. It belongs to Q. Root 25 over 49 equal 5 over 7. It's a fraction form, belongs to Q. Square root of 25 plus cubic root of 16. We know root 25 equals 5, and the cubic root of 16, we can't find the number time itself 3 times equals 16. So 5 plus cubic root of 16 doesn't belong to Q, it's belong to Q dash. The cubic root of negative 0.064, it's mean 4 over 10, it's a rational 4, so it's a rational number belong to Q. Cubic root of 25 over 49, we can't find the number time itself 3 times equal 25, so the cubic root of 25 over 49 belong to Q. Now find the solution set in Q dash. X power 2 equal 2. X power 2. As a power, we find the root. Power 2, we find the square root. Power 3, we find cubic root. Power 4, we find root 4s. X power 2 equals 2. X equal positive or negative root 2. Positive or negative root 2, it's belong to Q dash, rational numbers. So the solution set equal square root 2 or negative square root 2. X power 3 equals 5. As a power, we find the root. X to the power 3. So X equal cubic root of 5. It's a rational number belonging to Q dash. Solution set equal cubic root of 5. 4 over 3 x power 2 equals 1. Multiply the two sides by 3 over 4. So x power 2 equal 3 over 4 times 1 equals 3 over 2, 3 over 4. X equal positive or negative root 3 over 4 equal positive or negative root 3 over 2. Root 3 over 2 belong to Q dash, so we can write solution set equal root 3 over 2 and negative root 3 over 2. 0.001 x power 3 equals negative 8. The first divided by coefficient of x power 3. So x power 3 equals negative 8 over 0.001 equals negative 8,000. As a power, we find the root. X to the power 3, we find cubic root of the other side. So x equal cubic root of negative 8,000. X equal negative 20. Negative 20 doesn't belong to Q dash. So solution set equal 5 because find the solution set in Q dash. Note that any irrational doesn't irrational. The number is irrational number or irrational. So Q intersect Q dash equals 5. We know n subset of z in the natural number 0, 1, 2, 3, 4. Z is a positive and a negative and 0. Q any fraction form. Q dash any roots we can't find it as a rational form or approximate to pi. Approximated value of Q dash. Prove that root 3 lies between 1.7 and 1.8 by using calculators. By using calculators, we find root 3. It will be 1.7. It's between 1.7 and 1.8. Without calculator. Without calculator, we find the power of square root of root 3 equals 3. 1.7 to the power 2 equals 2.89. 1.8 to the power 2 equals 3.24. We find the root 3. Another example. Prove that cubic root of 12 lies between 2.2 and 2.3. We can check by calculator. Cubic root of 12, it will be 2.2 and the many numbers. It will be between 2.2 and 2.3 without calculator. Here, the cubic root of 12, we can give the number to the power 3. Then cubic root of 12 to the power 3 equals 12. Cubic 2.2 to the power 3 equals 10.648. 2.3 to the power 3 equals 12.167. So the cubic root of 12 it lies between 2.2 and 2.3. Again, we give the cubic root, we give to the power 3 of the two sides, and we find the cubic root of 3 greater than 2.2 and less than. Now represent the irrational number on the number line. If we want to represent root n on the number line, root n on number line, we used right angled triangle and use Pythagoras theorem. If we want to represent root n on a number line, we draw the right angled triangle and use Pythagoras theorem. If we want to represent root 7, now right angle triangle, the side is root 7 and the other sides it will 7 minus 1 over 2 and the hypotenuse it will be 7 plus 1 over 2. So if n equals 7, n plus 1 over 2, it means 7 plus 1 over 2 equal 4, and the other side n minus 1 over 2, 7 minus 1 over 2 equal 3. And drew the number line. From 0, we drew the perpendicular line, its length equal 3 centimeters. From 0, draw the perpendicular line, its length equal 3 centimeters. And by using the compass, but the compass, the over 0 and line segment from 0 3 centimeters, and the compass on the point over 0 and draw the arc, its length 4 centimeters from the hypotenuse. By using the compass, put the compass over the line perpendicular, its length equals the hypotenuse 4 centimeters, and draw the arc. The arc intersect the number line on root 7. So the root 7, if we want to represent the root 7 by using Pythagoras theorem. Another example, negative root 7. Negative root 7 as represent 7, but the direction on the left, on the negative side. Root 7 as represent root 7, but we remove the direction as negative direction. From 0, draw perpendicular line segment equal 3 centimeters. By using compass, open the compass 4 centimeters as hypotenuse length, and put the compass over perpendicular line and arc to the left. Why to the left? Because we want to represent a negative number. The arc intersect the number line as root 7. If we want to represent plus or minus, for example, 1 plus root 5. 1 plus root 5, we represent root 5, but we start with drawing the right angled triangle from 1. If n equal 5, 5 plus 1 over 2, the hypotenuse equals 3. Other side, 5 minus 1 over 2 equals 2. We draw the right angled triangle, but we start from 1. Start from 1. Draw line perpendicular equal 2 centimeters. Open the compass as hypotenuse 3 centimeters, and represent and draw the arc intersect the number line as 1 plus root 2 minus root 5, we represent root 2 minus root 3, we represent root 3, but we start from 2 and remove to the left. 3 plus 1 over 2 equals 2. 3 minus 1 over 2 equals 1. We represent the right angle, the triangle, but we start from 2 and remove to the left. Why remove to the left? Because we wanted to represent 2 minus root 3. From 2, we drew line perpendicular, its length 1 centimeter, and on the compass 2 centimeter as a hypotenuse length, and drew the arc from the left. Why we draw the arc from the left? Because we want to represent 2 minus root 3. The arc intersects the number line as a point 2 minus root 3. Now we want to represent 2 root 7. We represent root 7. We represent root 7. 7 plus 1 over 2 equals 4. It's hypotenuse length. 7 minus 1 over 2 equals 3. It's other sides. After we draw by using the compass, put the compass on 0 and on the compass to the arc on the number line, and put the arc on this, put the compass on this arc and draw other arcs. So second arc is 2 root. Example, find the two consecutive integers in which root 5 is included between them. By using calculators, we know by using calculator root 5 approximate to 2.23. So we take the integer number, it's 2. So root 5 included between 2 and the number greater than 2 is 3. So we can write the two integers 2 and 3. Root 12, by using calculator, we know root 12 approximate to 3.46. We take 3 and the number greater than 3, integer number greater than 3, it's 4. So the root 12 included between 3 and 4. What about cubic root 10? By using calculator. Cubic root 10, it's approximate 2.15. We take 2 and the integer just greater than 2, it's 3. So cubic root 10 included between and 3. Find the length of the side and the diagonal of the square whose area is 7. What about area of square? We know area of square according to side, it's side power 2. Area of square according its diagonals, half L power 2. So x power 2 equals 7. X side length. X equal positive or negative root 7, but square, its mean length, its mean only positive. Refuse the negative. So x equal root 7, the side length of square equal root 7 centimeter. Pythagoras theorem, L power 2 equal x power 2 plus x power 2. We find x power 2 equals 7. So L power 2 equal 14. L equal square root of 14